Okay, we will start. So, this course fish product and value addition. And the second next topic in this course is the drying of fish. In last class, we have studied about the salting of fish. So, like that, this topic is the drying of fish, and like salting, drying is also a oldest method of preservation. Like salting, drying is also one of the method of preservation, but this method is the oldest form. In earlier days, people were following this drying. Nowadays, because of the development of sophisticated instrument, several form of preservation techniques is applied, and we are getting a different varieties of processed and preserved food in the market. But this drying is still continuous process, and still it is widely and most commonly used practices, drying of fish. So we will study in detail about the drying of fish. So this drying of fish, as I told, it is the oldest method of preservation of food, and it is least expensive. We don't have to invest more amount of money. Drying is the process of removing liquid. If we have to define a drying, if some question is coming or if someone asks what is drying, then you have to answer it is the process of removal of liquid. From where? So from solid part. In our terms, our food is the fish. So if we are drying a fish, basically what we are doing, we are removing the liquid. That means water we are removing from the solid. Solid is the fish. So we are removing the water from the fish. So if we are removing the water from the fish, or if we are removing the liquid from the solid, then it is called as drying. Traditionally, in olden days, fish used to be dried under the sun. So if the fish dried under the sun, then it is called as sun drying. Your concept should be clear. There is a two terms called as drying and dehydration. Both are same, but the process which enhance the rate of drying will be different. So this is drying. That means it is a process of removal of liquid from solid, or we can say in our terms, the fish is dried. So what we are doing, we are removing the water from the fish. So traditionally in olden days, the peoples used fish that has to be dried under the sun. In earlier days, they were using the sunlight. So if we are drying the fish under the sun, then it is called a sun drying. Sun drying is carried out in open air. How we are doing this sun drying? So we are the entire process, we are drying the fish under the sun. That means open air. So in that sun drying, what we are using? We are using the solar energy. Why we are using the solar energy? We are using solar energy, to evaporate the water which present in the inside the fish body. So we are removing the water from the fish body by using the solar energy. That means we are using solar light, solar temperature. So if we are exposing the fish to the solar energy or solar light or temperature, so there will be a evaporation of water from the fish body. So water will evaporate. Generally, water is evaporating at what temperature? Water is evaporating at what temperature?
100 degrees Celsius.
So like that, here if we are exposing the fish under the sun, So solar energy if employed, so water inside the fish body will be evaporated, and this evaporated water will be carried out by air currents or air velocity. So in the environment, there will be air or velocity, air velocity. So when the water is removed from the body of the fish, air current or air velocity will take all this evaporated water or water vapor, and it will be dispersed into the environment. So this is the process of drying under the sun. The efficiency and quality of the products, it depends upon the climatic condition, because we are drying the fish under the sun. So if sunlight is there, temperature is there, good relative humidity present in the atmosphere, which is suitable for the fish drying, then our rate of drying will be faster. So it depends on the weather condition or climatic condition. अगर फॉगी वेदर रहेगा या फिर हमारा क्लाउडी वेदर रहेगा, then there will be a slower rate of drying, because there is a no sufficient light, there is a no sufficient relative humidity in the atmosphere, which is optimum for drying. So efficiency and quality of the products, it depends upon the climatic condition. So this is about the drying or sun drying. Then what are the disadvantages of this sun drying or drying? So we are depending on the weather. So always we have to dependent. That is the disadvantage. We have to depend on the climatic condition. Then here we require longer duration of time for drying. In case of sun drying, we require longer duration of time for drying, and we don't have a control over operating parameters. So what are the operating parameters which involves in the sun drying is the sunlight, temperature, air velocity, and relative humidity. We don't have a control because it is open air. Open air or climatic condition, we don't have control. It only having a control of God. So we are drying under the sun, under the open air, in the open air. So we don't have a control. So that is the disadvantage of drying or sun drying. Then possibility of contamination with dust, sand, then insects, etc. or microbes. Why? Because we are drying under the sun, open air. So if we are drying on the seabed or sea beach, or if we are using a platform having 1 meter height, so there is a possibility if the air velocity is means blowing, if the wind is blowing, so in the wind will carry a lot of dust, lot of means other sand, other particles, so that may fall over the product. It may also infest with an insect. Insect will attack on our product. So there is a possibility of infestation with insect. जो इंसेक्ट इन्फेस्ट करता है इस प्रोडक्ट पे, उस इंसेक्ट का ये मींस खासियत क्या होता है, they will eat entire life cycle, they will eat the product, they hatch means they lay the eggs, they hatch the eggs, and they will produce the larva, and they will also means remove their this excreta. So that is there is a possibility of contamination with a insect, sand, dust, infestation with insect, etc. Here we will get a poor quality of the product in case of sun drying, because we are drying under the sun, open air. So we are not getting a quality product because of the contamination with the sand, dust, microbes, insect. We are not getting a good quality product. Here the shelf life of the product will be less. So these are the some disadvantage of sun drying. Then coming to the dehydration, there are two terms I already told. One is a drying. Drying is the process of removal of water from fish body or body of the fish, or removal of water, removal of liquid from the solid. Dehydration also, it is a process of drying under controlled operational parameter. What are the parameters which involves in drying? Temperature, relative humidity, velocity of the air. These three parameters are most important, which influence the rate of drying. So if we are having a control over these three parameters, then we can achieve the quality product. We can achieve the faster rate of drying. So this, agar open air hai, if like in case of sun drying or drying, we are exposing the fish under the sun. We are keeping the fish under the sun for drying process. So we are not having a control over operating parameter. But in case of drying, we are having a control. Why we are having a control? Because we are using a closed environment. In that environment, we are placing our product. We are placing our fish. So how this dehydration concept came? Generally, why we are doing preservation? So aims of preservation and processing is to avoid wastage. Suppose हमारा plenty of catch है, means we are getting a quintals and quintals, tons and tons of fishes, but we don't have a market to sell our fishes, to sell our product. Then what we have to do? Whether we have to waste? No, we don't have to waste. So to avoid wastage, that's why we are doing the preservation. Second, aims of preservation and processing is to, first is the avoid wastage, and second, make it available at later time when these products having a limited availability in the market. When there is a limited availability or unavailability of that product, that time we have to sell this product. So that's why we are doing the preservation and processing. So drying, we don't have a control. So how we can achieve? So there is a development of mechanical dryer. There is a development of equipment which can enhance the rate of drying within a shorter period of time. And by using that equipment, by using that dryer, we can easily get the desired quality product. There will be a less contamination, or we can say there will be a no contamination until and unless the food handler, they are going to contaminate. So here we will get good quality product. There will be less contamination in terms of sand, dust, insect infestation if the packaging materials which is used to pack the fish will be good. So that is dehydration. Concept clear?
Yes, sir.
Dehydration and drying. Concept clear?
Yes,
Yes,
sir.
sir.
Okay,
Yes, sir.
good. Now, principle of drying. As we know, the water is a very essential for the activity of all living organism. Yes, anyone, someone is asking. Yeah, bolo. हेलो,
सर आवाज कट रही है.
अच्छा ठीक है, अभी सुनाई दे रही है?
यस सर, दे रही है.
Yes, sir.
So water is essential for the activity of all living organisms, including microbes. So principle of drying says what we are doing. Basically, we are removing the water from the fish or the food. So if this water is removed from the product or from the food or from the fish, then there will be a reduction in the water content. So if the water content is reduced, so there will be a reduction, or there will be a inactivity of microbes. Microbial growth will be stopped. Enzymatic activity will be stopped. That's why we are preventing the spoilage, and it results in the preservation. Principle of drying. Drying says we are removing the moisture. We are removing the water from the fish. So if we are removing the water from the fish, there will be reduction in the water content. So if there will be a reduction in the water contents, then there will be no growth of microbes or no activity of enzymes, because the water which supports the growth of microbes and the water which requires for the activity of enzymes, we are making unavailability. Why? Because we have removed the water. So there will be preservation. If we are removing the water, microbial growth will be stopped and enzymatic activity will be stopped. Then there will be no spoilage, and it results in the preservation. So this is the principle of drying. Then water content and related activity of microorganism. How this water content is related for the activity of microorganism. So in our fish, water content of fresh white fish means a non-fatty fish. If it is non-fatty, so in and around it contains up to 80%, some cases 90% also. On an average, water content of lean fish having a 80%. In some cases, it is up to 90%. If this water content, if we are reduced below 25%, then there will be a stoppage of bacterial spoilage. And if it is further reduced below 15%, then there will be a stoppage of molds growth. There will be no molds growth. So this water content we can express or we can define on a weight mass basis. So this is the MW. MW is the moisture content on weight basis. So that is the mass of water in the wet solid and total mass of the solid. That means how much water present in the fish divided by weight of the fish and multiply with 100. It will give the percentage of water content. This water content is not the most useful indicator of the ability of medium to support the microbial growth. Why it is not means useful indicator? So it will come, answer will come. Say for example, one is dried fish and another one is salted fish. Okay, in drying we have removed the water. We have removed the water. That means the water content of the dried fish is low, whereas we have applied a salt in salted fish, and there moisture content is more than the dried fish. Then which product will be spoil faster?
Salted product.
Salted product will spoil faster. Sorry, Amratya.
No, sir. No, sir.
Answer is wrong. Dried fish will having a moisture content lower compared to salted fish, which is having a moisture content or water content more than the dried fish, will spoil faster. Why? Answer is, in dried fish we are removing the water. Okay, so there will be reduction in water content. But in salted fish we are applying a salt. So if we are applying a salt, there will be a reduction in moisture content somewhat, because if we are applying a salt, so salt will penetrate and water will come out. At the same time, microbes will killed. At the same time, there will be inactivity of enzymes. Microbes will killed by plasmolysis process. That's why this water content is not the most useful indicator of the ability of medium to support the microbial growth. Then what is there which is going to support the growth of microbes? So answer will come now. So answer is the water activity. But before that, how this water activity will come, just water content versus water activity. You have to remember, water content is different and water activity is different. So there is several forms of bonds that occurs between water and protein molecules inside the fish body. There will be several forms of bond between the water and protein molecules of the fish inside the fish body. Then how many layers of water present in the fish? We are having a 3 layers: adsorption layer, diffusion layer, free layers. Sorry, free water. Adsorption layer, diffusion layer, and free water. All these three layers of water that will surrounds the surface of colloidal particles. That is your protein. So this adsorption layer, water at the adsorption layer may tightly bond to the colloidal particles. That means bound water. Adsorption layer में जो water है, that is your bound water. Then diffusion layer is less tightly bound to the adsorption layer. First is the adsorption layer, which is tightly bound to the colloidal particles. That means protein. So that is the bound water. Adsorption layer के बाद का जो layer है, वो है diffusion layer. That is less tightly bound to the adsorption layer. जितना adsorption layer का water है जो tightly हमारा colloidal particles और protein molecules के साथ bind रहता है, उतना diffusion layer का जो water है वो उतने tightly bonded नहीं रहता है colloidal particles से या फिर हमारा protein molecules से. It is less tightly bound to the adsorption layer. Then diffusion layer के बाद का जो layer of water है, that is called as free water. That means the water, this farther, the farther it is from the adsorption layer. Adsorption layer के बाद का जो है diffusion layer, diffusion layer के बाद का जो है layer, that is the free water. That is the third layer. Adsorption layer, diffusion layer, and third layer is the free water. Free water has all the properties of ordinary water and can enter into the normal reaction and supports microbial spoilage. So this is the only water which is helping in the supports and growth of microbes, as well as this water involves in the chemical physicochemical reaction inside the fish body, and this water generally participate in the spoilage of fish. Then what we have to do, whether we have to remove diffusion layer or adsorption layer or third layer, that is the free water. We have to remove this free water because this is only the water which is entering into the chemical reaction, as well as this water is supporting the growth of microorganism. So we have to remove this water. So in drying, what we are doing, we are removing the water. So that water is the free water. Understood?
Yes, sir.
Okay. Now, the free water is an important in drying process, as I already told, because this water is only which supports the growth of microorganism, and this water is only which entering into the physicochemical reaction inside the fish body. So this water activity, the most effective physical method for assessing the state of water in food is the measurement of water activity. So this water activity, generally we are expressing this small a and then subscript w, AW. So water activity is a measure of water available to support microbial growth and chemical reaction. What we are measuring in water activity? We are measuring the water which is available to support the growth of microorganism and chemical reaction. So this water activity is an important determinant. So this AW is the important determinant for what? It is an important determinant of microbial growth and metabolic activity, as well as of food deteriorating enzyme and chemical activity. So this water activity generally is a useful determinant, we can say, which supports the growth of microorganism as well as the physical chemical reaction which takes place inside the fish body after the death. So that's why water content is a not useful tools. Water activity is the important determinant. Concept clear?
Yes, sir.
Okay. Now, how we can define, already in earlier course and earlier semester we have studied the water activity. So basically this water activity we are defining as the ratio. Ratio of what? Ratio of vapor pressure on the surface of the product to the vapor pressure of pure water at same temperature. So this is the definition that was given. This water activity idea was given by a scientist called Scott 1957. He given an idea of this water activity. Then it is expressed AW is equal to P by P0. Okay, and this is the one of the instrument by which we can measure the water activity of a food. What we have to do, we have to take a sample, and then we have to feed into this water activity meter. This water activity meter. So we will get the how much water activity is there. So generally this water activity meter is the Nova Shin. Then water activity of pure water is 1. Don't forget, most commonly come in competitive exam. Water activity of pure water is 1. And if our product is absolutely dried, then the water activity of absolutely dried product is 0. But it is not possible. We can't achieve dried, means completely 0. For that, we have to ekdam macerate powder form, we have to get the product. Then only we can get this zero value. Water activity of salted fish is low compared to dried fish. Then fresh fish has water activity above 0.95. Fresh fish has water activity above 0.95. So these are the some water activity. You don't have to forget entire your undergraduate program, because most commonly come in all the competitive exam. You have to remember all these three, means 4, 3, 7, 7 or 8, 10 water activity. 0.95 basically microorganisms inhibits. That means growth of that microorganism stops. 0.95 or less than 0.95. At this water activity, gram-negative bacteria will stop their growth. 0.91, most spoilage bacteria, cocci, lactobacilli, will stop their growth. Their growth will be inhibited at 0.91 or less than that. 0.88, most yeast, 0.80, most molds and Staphylococcus aureus. Then most halophilic bacteria growth will be stopped at 0.75 or less than that. 0.65 xerophilic molds and 0.60 is the osmophilic yeast. You have to remember during the entire BFSC program, and most commonly you will get in your this JRF exam. So you don't have to forget. Then another thing is sorption isotherm. Sorption isotherm. Sorption isotherm, it is a convenient way of presenting the water activity characteristics of food stuff. It is a convenient way of presenting the water activity characteristics of food stuff. How? We have to plot a graph between equilibrium moisture content against water activity. So this is the equilibrium moisture content against water activity for a particular temperature or a range of temperature. So we will get, if we are plotting a graph between this equilibrium moisture content, this y-axis is the equilibrium moisture content and water activity, we will get a graph. So this graph, or we will get a curve. So this curve is called a sorption isotherm. Sorption isotherm, and generally it is a sigmoidal in shape. Understood? Sorption isotherm.
No, sir.
नहीं समझ में आया. Sorption isotherm.
सर एक बार फिर से बतला दीजिए सर.
If we want to present the water activity characteristics of a food or a fish, water activity characteristics को present करना है. How we can present? Then we have to plot the graph. We have to plot a graph between what? Between the equilibrium moisture content, y-axis जो भी value होगा, 10%, 20%, 50%. And then x-axis we have to plot a water activity. That means you take a sample and you have to dry on different moisture content, and that different moisture content, but at particular temperature we have to maintain. अगर हम कोई product having a 40% moisture content we are achieving at 45 degrees C or 50 degrees C or 60 degrees C, the same we have to used for water activity. So that product we have to feed into this water activity meter. We will get the water activity of that product, and then we have to plot the data. 50% moisture content having a water activity of this much. So you will get a curve. You will get a curve. Yeah, if we are means continuously 10% to 90% or 100% if we are plotting. So you will get a curve. So that curve, if you are getting, that is called as sorption isotherm. So generally, we are plotting this graph between the equilibrium moisture content and water activity. So we are getting a curve, and that curve is called a the sorption isotherms. And that generally it is in the sigmoidal curve, means shape, sigmoidal shape. Any confusion? Any confusion?
No, sir.
समझ में आ गया?
Yes, sir.
ओके, कुछ नहीं है, वाई एक्सिस में जो मॉइस्चर कंटेंट है उसका डाटा फिट करना है, और वाटर एक्टिविटी का जो डाटा है वो हमको एक्स एक्सिस में लेना है, और जो पॉइंट्स आएगा उस पॉइंट्स को ज्वाइन करते जाना है, तो वी विल गेट ए कर्व. सो दैट कर्व इज कॉल्ड एज sorption isotherm. जनरली इट इज इन sigmoidal shape.
सर कर्व निकालने से क्या मतलब कि इम्पोर्टेंस क्या है, इससे क्या हम लोग का एडवांटेज होगा?
You will know, suppose we are having a 0.4 water activity. At that 0.4, how much percentage of water is there? How much percentage of water is there of that product? You will know. At the same time, you will also know, suppose 40% of water is there. So 40% of water of that product having how much water activity? So you will know. So you will get a curve. You will know ना, अगर वाटर कंटेंट हमारा रिड्यूस हो रहा है तो वाटर एक्टिविटी भी रिड्यूस हो रहा है क्या, या नहीं? तो अगर हमें वाटर कंटेंट बढ़ रहा है तो क्या हमारा वाटर एक्टिविटी भी बढ़ रहा है?